Okay, so for example, this is optical tomography. I said you can here you put some devices on your head, measure the shining lights and measure the responses. You can measure like the blood volume. This is it's not so visible. And this is about breast cancer, some tests on that. And this is fluorescence tomography. As I said, you put some markers here. The fluorescence tomography, you need to shine lasers onto the body, then they will excite these biomarkers or dyes. And then from receiving the light, you know where it is. You can monitor like the tumor, where it is, and growth, so on and so forth. Similarly to the bioluminescence tomography, in that sense, the source is right inside. You don't have to use any external source to excite it. But anyway, the thing is you want using this light propagation, how light propagation in the tissues, to know some optical property of the tissue, and from that infer its functionality, healthy, non-healthy, benign or malignant, and so on and so forth. Okay, so now this is typical setting in optical imaging. Let me tell you where mass play a fundamental role. Okay, so in the imaging, to me, is always black box. You go in there, doctor sends some, put some equipment on you. Maybe they send some pulses into your body, and they show something on the computer. That's basically what's inside. Well, how this black box works is basically say you know what you send in, you know what's coming out. The question is, what's inside will match these two. That's basically has to be a mathematical model. Okay, so in our case, you have to say how light propagate in tissue. Given this, I assume I know the optical property, then I can predict what's coming out. Most of the time it's not correct, because otherwise you already know the answer. So you know the differences from here to here. Then, as I said, the prediction from input to output is called forward model. You need the mathematical model. And then after you know there are some mismatch, because your initial guess cannot be that good, and then you have to see from this mismatch, how do I correct my model to match with the real data? And that process is this analysis scheme. You have to, from the differences, know how you correct your initial guess. By maybe many iterations, you can find better and better reality. Okay, so that's the whole process. Okay, so the first thing I said, when you try to learn this, you have to study how light propagates in tissue. And that tells you if you measure this, a response, then you basically know what are the optical property of this tissue. So there's already a lot of physical study, mathematical study about light. The question is, again, in reality, the world is far more complicated than us. Than we can deal with. So the thing is, you always have to choose the right model. When I say model, there's an absolutely true model, but that model is usually too complicated or out of reach, even with our modern computer powers. For example, Maxwell equation. Everybody knows this equation, but just nobody can deal with. Either, even with our modern computer, the advantage of this complicated model is it's very accurate and it's very good for general purpose, but the problem is you have to resolve the wavelength in order to solve this. I don't want to get too much into the detail, but the wavelength is so small, you cannot do that. Even the supercomputer cannot do it. So you have to relax your model a little bit so that it's still quite faithful, but require less effort. That's, again, mathematics is very, very helpful to tell you what is a good thing. Another thing is you're using physics. I say this low intensity, low frequency wave, when you get into the body, it's very complicated. It interacts with the tissues, it's scattered, it's not going straight, not like particles. But then one thing you can do, you can jack up the frequency using more advanced technology, energy. And then you have a very simple model, which is for the X-ray, which has been used. It's simple, and we know the inverse Radon transform is available. But the question is, it only works for high frequency and high energy. First, it hurts your body. Second of all, it only provides anatomical information. You want more than that.